Howdy, howdy, howdy. This is a review. This is 9-1 Notes Part 1. And this is a review of simplifying radicals. This is part 1, and the second part will be solving quadratic equations. So a review of simplifying radicals has 3 key ideas. And the first key idea is to simplify a radical by writing the radicand, or the inside number, as the product of two numbers, one of them being the largest perfect square factor. Now, perfect squares, these are numbers like 4, 9, 16, 25, and so on. So, for example, the square root of 48. The largest perfect square that's a factor of 48 is 16. So this is equal to 16 times 3. Okay, now the 16 comes out as a perfect square of 4. So the square root of 48 is equal to 4 times the square root of 3. That's how you simplify a radical. Okay, so that's one main idea. The one first key. The second key is to combine like terms. And an example of that would be the square root of 18 plus the square root of 32 plus the square root of 75. And the first thing you do with this problem is apply first idea. And to apply the first key, you're going to write the square root of 18 as the square root of 9 times 2, because 9 is the largest perfect square factor of 18, plus the square root of 16 times 2, plus the square root of 25 times 3. The 9 comes out as a 3. The 16 comes out as a 4. And the 25 simplifies and comes out as a 5. So this expression is now 3 times the square root of 2, which is equal to the square root of 18, plus 4 times the square root of 2, which is equal to the square root of 32, plus 5 times the square root of 3. Now we're going to apply second key. Second key idea, which is combine like terms. So the answer is 7 times the square root of 2 plus 5 times the square root of 3. That's the second key idea to simplify radicals. Okay, the third key idea here, we call this rationalizing the denominator. Which is removing, okay, rationalizing the denominator, which is removing radical from denominator if there is one. To do this, okay, you're going to multiply top and bottom by radical in bottom. So multiply the numerator and denominator by the radical that's in the denominator. For example, if I write the square root of 5 over 3, first you have to apply, you're going to apply the square root of a over b is equal to the square root of a over the square root of b. You're going to split it. Or you're going to apply that split. So you write the square root of 5 over 3 as the square root of 5 divided by the square root of 3. Now, if there's a radical in the bottom, then you have to apply the third idea, which is rationalizing the denominator. So in this problem, I'm going to multiply numerator and denominator by the radical in the, whatever radical is in the denominator, just the single radical. Square root of 3 over square root of 3. So I'll do this. All right, this is the third idea here, third key idea. So now this radical becomes the square root of 15 over the square root of 9, which simplifies to the square root of 15 over 3. Now, or I can write this as 1/3 because there's an invisible 1 right here, times the square root of 15. Notice there's no square root in the bottom. Square root in bottom is removed. Okay, so that's how you handle that situation, and I do hope that if you have questions, you will message me. So if going back, you're going to apply 3 key ideas to simplifying radicals. The first key is to simplify a radical by writing the inside number as the product of 2 numbers, one of them being the largest perfect square factor. If I have a problem like the square root of 48, the square root of 48 can be written as the square root of 16 times 3, which is equal to the square root of 4, or 4 times the square root of 3, because this 16 inside the square root comes out as a 4. The second key idea is to combine like terms, and the square root of 18 plus the square root of 32 plus the square root of 75. After I apply the first key idea to the square root of 18, and I write it as 9 times 2, and out comes a 3. 16 times 2, out comes a 4. And 25 times 3, out comes a 5. Now, these two radicals are like each other, so they can get combined. But this one is different, so it has to be kept separate. All right, That's the second key idea. The third key idea is rationalizing the denominator, which is removing a radical from the denominator if there is one. Multiply top and bottom by radical in the bottom. That's really what you need to remember. So if you have the square root of 5 over 3, you can apply this rule here, which is the splitting rule, which is the square root of a over b is equal to the square root of a over the square root of b. So this, the square root of 5/3 is equal to the square root of 5 over the square root of 3, and then I don't want that square root in the bottom, so I multiply top and bottom by the square root in the bottom. And this is how this simplifies. See, the square root of 3 times the square root of 3 is equal to the square root of 9. And the square root of 5 times the square root of 3 is equal to the square root of 15. We can't simplify that because there's no perfect squares that go into 15. And then, but you can see, though, that the square root of 9 simplifies to 3. So the square root of in the bottom is removed. The radical in the bottom is removed. All right. Have a good day.